Assalamualaikum warahmatullahi wabarakatuh. Now we shall continue our lesson on topic 3.4 Implicit Partial Differentiation. By the end of this topic, you should be able to determine partial derivative using implicit differentiation. Before we go further, you should be able to determine whether the function is written in its explicit form or implicit form. Basically, an explicit function is one which is given in terms of independent variables, such as y, which is the subject of your equation, is equal to some independent variables, which in this case, y is equal to x squared plus 5x minus 7, where you can put the dependent variable on the left hand side, meanwhile the independent variables is on the right hand side. Meanwhile, on the other hand, implicit function is usually given in both dependent and independent variables. If you look carefully to the example given, so basically you cannot separate the dependent variable and independent variables. So normally, if the question asks you to determine the derivative of the following implicit function, so let's try to solve this example together. Okay, when you have this type of equation, if the question or if the author asks you to determine what is dy dx, so basically what should I do? I have to remember that y is a function of x. So I have to differentiate y with respect to variable x. So in this case, what should I do is that I will have 2y dy dx plus, for this expression 5xy, I have to apply product rule. So in this case, I will factor 5 out and then I will focus on differentiating xy by using product rule. I will get x dy dx plus y, differentiate x with respect to x, I will get 1. So that's it. Then I will focus on differentiating whatever I have on the right hand side. I'll get equal to 8 dy dx plus 5. But you have to remember the question asks you to determine dy dx. So what should I do? I have to rearrange everything related to dy dx on the left hand side. Meanwhile, whatever variable that is not related to dy dx, I will put on the right hand side. So in this case, I will get 2y dy dx plus 5x dy dx minus 8 dy dx equal to 5 minus 5y. By factoring dy dx, I will get dy dx 2y plus 5x minus 8 equal to 5 minus 5y, and dy dx equal to 5 minus 5y divided by 2y plus 5x minus 8. When you learn about function of a variables, so basically this is the approach that you will use to solve, to determine derivative of function written in terms of implicit form. But when you go through lesson 3.2, which you learn already how to determine derivative of function of two variables, by right, you will see that there is a formula to determine the derivative of function of two or more variables by using partial derivative. Therefore, there's always another way to answer this question. You will see that the answer is quite simple compared to the process you go through when you approach using implicit differentiation. So if you turn to page 194, there you go, that is the formula by using the approach of partial derivative. So let's take a look at the question given to us, and then according to the formula on page 194, you have to rewrite the equation given to you and equate it equal to 0. This is the important process, or else this formula won't be valid. So you have to find what is function xy equal to 0. In this case, I will get y squared plus 5xy minus 8y minus 5x equal to 0. Then, according to the formula that has been shared on page 194, dy dx can be determined as simple as negative fx divided by fy. So fx represent partial derivative of the function with respect to variable x, and vice versa. So you will see as if the formula alternate from left hand side to right hand side, in the sense of, if the question asks you to determine dx dy, the formula will be the other way around, such as negative fy over fx. So if you are interested in knowing how it turns out to be this kind of formula, you can refer to page 194. So basically, the formula asks you to determine partial derivative with respect to variable x and partial derivative of the function with respect to variable y. So what should I do? I have to determine partial derivative with respect to x. I have to assume variable not related to variable x as a constant. In this case, I will treat y as a constant and y should behave like a constant. I will get 5y minus 5. Meanwhile, if I want to determine partial derivative with respect to variable y, I need to treat x as a constant and x should behave like a constant. I will get 2y plus 5x minus 8. And then what should I do right after this? I can simply substitute into the formula, such as dy dx equal to negative fx. fx equal to 5y minus 5 divided by 2y plus 5x minus 8. You can compare the answer. The answer is similar. So if I were you, I will use the formula to determine the derivative of function of two or more variables instead of using implicit partial differentiation. Okay, so let's take a look at the example. Okay, I believe I don't have to describe or explain about example 3.4.1 because the way to solve the problem is similar to what I have shown to you earlier. Okay, so let's take a look. If you have function of three variables that is written implicitly. Okay, so right now, for example, according to the formula on page 195, if you have this type of function f, x, y, and z, if the question asks you to determine what is del z over del x, so in this case, you will get this kind of formula such as negative fx over fz. Del z del y, you will get negative fy over fz. So as I mentioned earlier, the formula will alternate with each other. you can use the formula explained on page 195 in case you forget, because when it comes to this topic, we normally don't give you the formula because the formula will vary according to the question given to you. So let's discuss about this formula. Okay. So let's try to answer few questions related to this type of example. Okay, I will try to show to you both ways to solve the problem. Okay, for example 3.4.2, the question asks you to determine del z, del x, and del z, del y for the following function written in its implicit form, such as y cubed plus 3x squared y minus 2x squared plus z squared equal to 5. So let's try to answer this question by using implicit method and followed by using partial derivative approach, which is by using the formula. So right now, what should I do? This is method 1, and then the question asks me to determine del z, del x. Okay, if you have this question, okay, by using the first method, you will determine the derivative left hand side and right hand side. I will get y cubed plus 3x squared y minus 2x squared plus z squared equal to del x 5. Okay, what should I do right after this? I have to find the derivative left hand side and right hand side. So right now you have to make up your mind. When the question asks you to determine del z, del x, variable that is not related to z and x, you will treat it as a constant when you try to use implicit method. So in this case, I will treat y as a constant, and at the same time I have to realize z is a function written of variable x and y. So what should I do right now? Since y I will treat as a constant, I have to make sure it behaves like a constant. So differentiate y cubed with respect to variable x, I won't get any value, which is I will turn out getting 0. So I will get 6xy minus not 2 minus 4x plus 2 z del x equal to 0. Therefore 2z del x, variables not related to del z del x, I'll bring to the right hand side. So I will get equal to negative 6xy plus 4x, and del z del x equal to negative 6xy plus 4x divided by 2z. Okay, you can leave it as it is, or if you look on page 196, the author try to simplify the answer. Either one is acceptable. Okay, if we look at method 2, which is much simpler compared to method 1, for method 2, use the formula such as del z del x equal to negative fx over fz. Again, when it comes to problem involved with topic 3.4, the exact formula won't be given because the formula will vary according to the question given to you. Please take a look at the question. Therefore, what should I do in this question? I have to determine fx and fz, which is partial derivative of the function with respect to variable x and with respect to variable y. Therefore, what should I do? I have to rewrite the question or the equation given to me and equate it equal to 0. This is necessary, or else your answer will be invalid. So in this case, I will get y cubed plus 3x squared y minus 2x squared plus z squared equal to, not equal to 5, minus 5 equal to 0. Therefore, fx equal to, so when I try to determine partial derivative with respect to x, I will treat y and z as a constant. So it will be quite confusing if you try to go from method 1 until method 2, but you have to hold the principle right, or else you have tendency to confuse between method 1 and method 2. Method 1, we are dealing with solving the equation by using implicit differentiation. Meanwhile, method 2, we try to solve the problem by using partial derivative approach. Therefore, what should I do? For this one, I will treat y and z as a constant. Therefore, I will get 6xy minus 4x and fy equal to 3y squared plus 3x squared. No, the question never asked me about fy. So what should I do? I have to relook to the question. Okay, I need to delete this one. If the question asks me to determine del z del x, I have to determine partial derivative with respect to x and partial derivative with respect to z. Therefore, fz equal to as simple as 2z, and then you can simply substitute into the formula del z del x equal to negative 6xy minus 4x divided by 2z, which is similar to the answer you have obtained from method 1. Okay, we as a lecturer, normally we will advise the student to answer the question by using method 1, because if you have access to the question from previous semesters in the final assessment, normally the function won't be that easy. If you want to solve the problem by using method 1, which is you try to appreciate the mathematics behind it, you will feel the excitement and the enjoyment to solve the problem by using method 1. But to make sure you are on the right track, so basically we will always advise the student to use method 2. So let's take a look at the next example, which is this question here. 3.4.3. Okay, you have been given with this question to learn set x squared plus y squared plus 2xy z cubed equal to 6. Okay, you can use, okay, I will show you to all of you method 1 and method 2. So in this case, if I have this type of question, even though it is written in terms of some complex representation, so you can always recall the properties so that you are able to deduce the function into simpler terms. As you can see on the first term, by using the properties of the logarithmic function, you can always bring the coefficient behind it. So in this case, I will get ln insert x squared plus y squared squared plus 2xyz cubed equal to 6. This one is by applying the logarithmic property. Then I can simply get ln x squared plus y squared plus 2xyz cubed equal to 6. Okay, so right now I will try to determine del z del x. So method 1, we go for method 1. Okay, how to solve? So you will find the derivative left hand side and right hand side. I will get del x ln x squared plus y squared plus 2xyz cubed equal to del x 6. And then the question asks me to determine del z del x, and variable that is not related to z and x I will treat as a constant. In this case, I will treat y as a constant. Therefore, I will get 1 over x squared plus y squared del x squared plus y squared. Okay, we try to focus on one term to another. And then okay, plus I will factor 2 and y out because I will treat these two variable, which is a constant 2 and variable y, as a constant. Then I have to focus on del x z cubed, and on the right hand side you can simply get 0. In this case, del x of x squared plus y squared will give me 2x. So very simple. On the first term, I will get 2x over x squared plus y squared. Okay, it will be quite messy on the second term in the left hand side, which I have to apply product rules, since it is actually multiplication between variable x and z cubed. I will get x 3z squared del z del x plus z cubed equal to 0. And then I have to realize the question asks me to determine del z del x. So variable that's not related to del z del x I will bring to the right hand side. Therefore, I will get not 2 times 3, which is 6 x y z squared del z del x equal to negative 2x over x squared plus y squared minus 2yz cubed, and del z del x equal to negative 2x over x squared plus y squared minus 2yz cubed divided by 6xyz squared. Okay, you can leave it as it is, or you can try to simplify your answer. So my suggestion is that leave it as it is. No need for you to simplify your final answer. Okay, still think to solve the problem using method 1, which is quite messy if you don't get the facts right. So let's take a look how simple it is when we use method 2. Okay, if you use method 2, del z del x, the formula will be negative fx over fz, as simple as that. So what should I do with this question? I have to rewrite the equation given to me and equate it equal to 0 in order to apply using this formula. As simple as that. Fx, y, z is equal to 0. So I will try to rewrite the equation. Then I will get ln x squared plus y squared plus 2xyz cubed minus 6 equal to 0. Therefore, I have to determine partial derivative with respect to x, where I will treat y and z as a constant. In this case, I will get 1 over x squared plus y squared. Differentiate x squared plus y squared with respect to variable x. You will treat y as a constant. Again, you will get 2x squared. Okay, in this case, in the second term, you will treat y and z as a constant. Then you will get plus 2yz cubed, and differentiate 6 with respect to x. You will always get 0. Then determine what is fz. So on the first term, there is no variable z. Therefore, the whole term is actually a constant. Differentiate the first term, which is a constant, with respect to variable z. You will always get 0. And on the other hand, fz for this question only appear on the second term, which is you will get 6xyz squared, and differentiate 6 with respect to z, you always get 0. Then you can simply substitute into the formula, such as dy dx equal to negative 2x squared over x squared plus y squared plus 2yz cubed divided by 6xyz squared, which happen to be similar to the answer you obtained from method 1. Again, do you want to solve the problem using method 1 or method 2? Okay, ask yourself. If you love challenging, you can always use method 1 and verify your answer using method 2. So make up your mind and always choose method 2 because it is easier that way. I hope you can spend some time to take a look at application problem on page 200. Basically, the approach is similar. You can choose to solve the problem by using method 1 or method 2. The idea is that you should understand the application problem given to you. So I'll let you to discover on your own, and then I will let to discuss question number 3 for exercise 3.4. I will answer a part of it, which is determine del z del y of the following function x squared plus z cosine xyz equal to 3. So let's try to solve it by using method 1, which is solve it by using implicit differentiation. In this case, del z del y, variable that is not related to z and y, you will treat as a constant, and it should behave as a constant. In this case, x should behave like a constant. You apply derivative for both sides. Del y x squared plus z cosine xyz equal to del y 3. Again, x is a constant. Differentiate with respect to y for variable x will give you 0. And z is a function written in terms of variable x and y. So in this case, you have to apply product rule, which is u v prime plus vu prime. So in this case, we call this one as u and we call this one as V. Then what should I do? Okay, I will get Z del y cosine x y z plus cosine x y z del y z equal to 0. So in this case, I will get Z. Differentiate cosine will always give you negative sign x, y, z. And at the same time, the argument of this sine function, there are variable x, y, z. So again, you have to differentiate the argument of your sine function. Therefore, in this case, you have to again apply product rules, such as this question, product rule inside product rule. So I will have to factor x out since x is a constant, and then I will get y del z del y plus z. Okay, you have settled the product rule of the argument of sine function. Don't forget, you still have to solve the rest of it. Okay, and then I will have plus cosine x y z del z del y equal to 0. Okay, I think that's it. So we can try to rearrange the question so that we can group del z del y on the left hand side, and variable that's not related to del z del y we put on the right hand side. So in this case, del z del y belongs to negative x y z sine x y z, okay, plus cosine x y z equal to not negative, since we bring it on the right hand side, I will get positive at z squared sine x y z, and del z del y equal to xz squared sine x y z divided by negative x y z sine x y z plus cosine x y z. So let's take a look on the example whether we get the same answer. Yes, the same answer. Okay, you can always use method 2 to solve the problem. So method 2, which is as simple as by using the formula del z over del y equal to negative fy over fz. What should I do? I have to rewrite the equation, equate and equal to 0. This one is crucial and important, or else we can nullify the rest of your answer, because there is no summation or there is no assumption as fx yz equal to 0. So I will get x squared plus z cosine x y z minus 3 equal to 0, then determine partial derivative with respect to variable y by assuming x and z equal to constant, and it should behave like a constant. In this case, I will get z negative sine x, y, z. Don't forget to always differentiate the argument of sine function with respect to variable y. You will get z. Okay, if I try to simplify the answer, I will get negative z squared sine x, y, z. And determine partial derivative with respect to variable z. So in this case, the first term, there is no variable z, therefore all the way 0. But at the second term, there is z for both function, which is z, and at the same time cosine x, y, z. So we will apply product rule to solve the problem. Okay, I will get z, okay, in bracket, negative sine x, y, z. Differentiate x, y, z with respect to variable z. I will get x, y. I think that's correct. Then I get cosine x, y, z. If I try to simplify the answer, I will get negative x, y, z sine x, y, z plus cosine x, y, z. Then I simply substitute into the formula del z del y equal to negative in bracket negative x z squared sine x, y, z divided by negative x, y, z sine x, y, z plus cosine x, y, z. Okay, x z squared sine x, y, z. So let me cut this one. No need for me to rewrite everything all over again. Here. Okay. So the answer is similar. Method 1 and method 2 will give you similar answer. I really hope you can do a lot of exercises just to practice your differentiation skills, so that you don't get easily confused when we discuss by using to solve the implicit partial differentiation by using implicit differentiation method 1 or by using method 2, which is more simpler compared to method 1, which is you can apply the knowledge you have gained in topic 3.2, which is partial derivative. Okay, see you again in another video. Don't forget to subscribe and like the video. Bye.